This is number 114. Then there's a page 58, 5.3.3 extension. Okay, let me close this one. Extension. So what was the one before? What was the one before was a stretch. Okay, stretch. Now it's called extension. I don't I don't understand much the difference between stretch and extension. It's a little bit strange. So extension, stretch. Okay, okay. Stretch. Stretch is more like a ratio. Yeah, okay. So stretch is like if you have, what was the definition? There was definition. Large E, large lambda, small s, large s. It's small s, so maybe large s. So this is a stretch. How if you call original one 1, then this is a 1 plus delta. This is stretch. Then this delta part is extension. So this delta part is extension. So you subtract 1 from stretch. Then this is extension. Extension is a stretch minus 1. Extension is a stretch minus 1. I'm a little bit confused. I thought this is almost same. I thought then wasn't this correct? By definition, I think it was like that. Stretch, stretch, stretch. Only the direction is different. No? Anyway, so then extension, stretch, deformation, and strain are related in the form. Extension, stretch, this is deformation and strain. Extension, deformation, stretch, deformation, strain. Am I correct? E is E called strain. Strain tensors with deformation. deformation gradient vectors. Complicated. Deformation. What is deformation? Green deformation vector. Deformation tensor. Okay, deformation tensor. Let me see. Okay, this is deformation tensor. Strain. This is deformation tensor. Yeah. So G is a deformation tensor. E is strain. E is E strain. Strain. Yes. Almancy strain. Cauchy strain. No, Almancy strain is approximately equal to the symmetric strain. Further as this. Almancy strain. Lagrange strain. Cauchy strain. Green strain. Large E is green strain. Small e is Almancy strain. Large E is Lagrange strain. Small e is Cauchy strain. Anyway, so there is such relation. Infinitesimal strain and rotations. When the difference between d small s and d large s is small, for element initially in the one direction, we find stretch square minus 1 is something like this. Is this E, 2E, 2E, 1, Y, using complicated. How do you get it? This is more like ds d large S minus 1 ds d large S plus 1 Yeah, then that means we go by large E. So this is more or less this thing is square root E2E11 plus 1 minus 1. And this thing square root 2E11 plus 1 plus 1. Minus 1 plus 2. Yeah, so you just get this one. Okay? Infinitesimal deformation of rectangle using ds plus ds large divided by ds large is approximately 2 E11 is extension. Extension is d small s minus d large s divided by d large s, which is the elementary definition of strain as the ratio of, this is not a stretch. Is this stretch or extension? Is it extension? See, lambda is stretch, right? Is it lambda stretch? Yes, lambda is a stretch. Lambda is a stretch, so this is more like extension. Why this is called a strain? Elementary definition of strain as the ratio of change in length. Okay, strain, because this is stretch. But then this is extension, right? Was it? This is extension. I get confused. So I think this is extension. Here, this is extension. So this is extension. This is extension. I got confused. Okay. which is the elementary definition of strain as the ratio of change in length to the original length. I thought this means extension. Anyway, consider rectangular material element OACB with O at x1, x2 and OA equal dx1 and OB equal dx2 as shown in figure 5.4. During the deformation, O moves by U1, U2 to O prime. So actually O moves. So it's strange. Here I think this has to be connected. So O moves to O prime. A, B, C, and end up at A prime, B prime, C prime. Using the rigid body translation, we can move the element back to make O prime coincide with O. Then the relative coordinate of the other points are A prime is something like this. B prime is something like this. A little bit confused. Dx. Okay. Assuming small displacement derivatives, we find E11 equal partial 1 U1 E22 partial 2 U2. The counterclockwise translation, counterclockwise rotation, theta 1, 2 of OA and theta 2, 1 of OB are obtained as this. I think we have too much definitions. Small displacement derivatives. We have to go back to the original definition. Okay, maybe I need to work out in my note. I don't understand quite well. So let me stop here. 59 page. Next one. Next one is 59 page. Equation 5.59. Okay, this is what I will do next. Let me see. Let me change the number. Change. Okay. Okay, so see you next time.